Here are the notes for Unit 5, Geometry Quadrilaterals. What is a quadrilateral? A quadrilateral, and this is an introduction to quadrilaterals and trapezoids. So, what is a quadrilateral? Well, the word quad, or the prefix quad, has the number 4 in it, right? Quad means 4. And so a quadrilateral is literally a 4-sided figure with 4 vertices, a closed polygon, or a polygon with 4 sides and 4 vertices. Here are some examples of quadrilaterals. Here are some non-examples of quadrilaterals. This one having 5 sides makes it a non-quadrilateral. This one being an open figure as opposed to a closed figure makes it not even a polygon, and we know quadrilateral is a polygon. And this is clearly a triangle, which is very different from a polygon, or rather a quadrilateral polygon, okay? What types of quadrilaterals are there, and what type are we going to learn about? There are generic, these two would fall under the category of generic polygons with no, or quadrilaterals with no unique properties. Trapezoids, isosceles trapezoids, parallelograms, rhombuses, rectangles, and squares all have unique properties that you're going to learn about. Okay, and so let's do this quick pulse check. A quadrilateral is, so we're just responding always, sometimes, or never true. A quadrilateral is sometimes a rectangle. It's not always a rectangle, but it is sometimes a rectangle, okay? And a square is always a quadrilateral, okay? A square by definition is a quadrilateral with unique properties, okay? And a pentagon is never a quadrilateral because a pentagon has 5 sides, okay, and 5 vertices. But now let's talk about trapezoids, which is a type of polygon, a type of quadrilateral that has some unique properties. A trapezoid, by definition, is a quadrilateral with 1 or more pairs of parallel sides. So it's a quadrilateral with 1 or more pairs of parallel sides. Here's 1 pair of parallel sides. It looks like it's the only pair. That's indicated by these arrows here. And it contains 4 angles within the quadrilateral. Because it is a quadrilateral, it has 4 sides and 4 vertices, which would create 4 angles. So what's important is the relationship between the angles that are in this trapezoid. Each pair of consecutive angles that lies between the parallel sides is supplementary. So same side interior angles are supplementary. That's something that we knew. 2 parallel lines cut by a transversal will have same side interior angles be supplementary. And that's why that's the case here. Okay, so angle 2 plus angle 3 will give you 180. Angle 1 and angle 4 would give you 180. They are not congruent, they are supplementary. Then we come to isosceles trapezoids, okay? So we had a very quick discussion about trapezoids, but what about a unique type of trapezoid known as an isosceles trapezoid? And that is this figure right here. It is, by definition, it is a trapezoid with exactly 1 pair of parallel sides. 1 pair of parallel sides. This is the pair. It only has 1. Isosceles trapezoids only have 1 pair of parallel sides. And of course, by the arrows, we know that these are it. Okay, these are the parallel sides, and congruent non-parallel legs. So of the 4 sides in a isosceles trapezoid, the 2 non-parallel legs are congruent. The other 2 sides are parallel to each other. Within the trapezoid itself, the isosceles trapezoid itself, the angles at the bases are congruent. Okay, just like in isosceles triangle, two legs or two sides are congruent. Their two angles at the bases are congruent as well. So these two angles are congruent. These are supplementary. Again, same side. Interiors are supplementary. These two, which are on opposite sides, are supplementary. Congruent. Okay, so these are congruent, those are supplementary, and so are those. Okay, so let's apply that information to try it out, okay? So what you're just going to be doing for this one, it says in trapezoid MNPQ, these two sides are parallel. So I'm just going to draw a traditional or just a regular trapezoid. And if I have to change it to an isosceles just because of the measures, I will. But for now, I'm just drawing a regular trapezoid, okay? So it says here, angle M. It says MN, so side MN. So very important. If we know that these sides are parallel to each other, the way we're going to name this has to be based on that. So MN is congruent to MNPQ. Okay? MN is, parallel to QP. All right? And M is 108 degrees. And angle P is 4x minus 15, and that's 3x plus 21. Because the bell just rang and I am out of time, we will continue to try it out in a part 2 video.